In this first video, we're going to start looking at number. The first topic we're going to look at is non-calculator multiplication. There are lots of different approaches that you could use. The grid method is just one of them. So here we're asked to multiply 231 by 49. I've simply split 230 and 1. So we've got the hundreds, the tens and the units. I've got now the tens and the units, and we've gone ahead and multiplied them. So let's have a go at an example. Let's do a 2-digit number by a 3-digit number. So let's say we wanted to do 42 multiplied by 137. So all I do is set this up in a grid. So we're going to have 42 and 137. So I'm going to have now along the top, I'm going to have now, and I can have either, I can have the 42 or the 137. It really doesn't matter. I'm going to put the 137, so I'm going to split this up into 100, 30 and 7. We're going to multiply this by 42. I'm going to split this up as 40 and 2. So I split it as tens and units. 4 times 1 is 4, and then add the 3 noughts. That gives me now 4,000. Now I'm going to do 4 times by 3, which is 12, and I'm going to add the 2 noughts. So I'll have 1,200. 4 times by 7 is 28, and then we add the 0. 2 times 1 is 2, add the zeros, or of course you can just say that's 200. 2 times 3 and add the 0, or if you like, 2 times 30 is 60. 2 times 7 is 14. All I'm going to do at this stage is simply add these up. Now it's really important that you keep these in order. So what I'm going to have then is 4,000. And if you're doing this in your book, do it in squares so you can keep now these in the order that they appear. So for example, I'm going to have my thousands column, my hundreds column, my tens column, and my units column. So just going along the top, we're going to have now 280. Then we're going to have 200. We're going to have 60. And we're going to have 14. I simply need to add down. So I've got all the zeros and then a 4. That's going to give me 4. I've got 8 and 6, which is 14 plus 1. That's 15. I write 5 in, and then I carry the 1. I've got 6 plus the 1 is 7. And then finally, 4 plus the 1 is going to give us 5. So our final answer is 5,754. When you revise at home, do check. Just grab a calculator out and just check. So 42 times by 137 will give us now the answer that we want of 5,754. Okay, so that's an example. That's now just 2-digit by 3-digit. If we had, let's say, and we'll change this over, let's say we had now 4.2 times by 137, we could do exactly the same and then reintroduce the decimal point. I can see that I've got a total of 1 digit after the decimal to start with, so my answer in this case would be 575.4. Often students struggle with the idea when they have this decimal in. It really doesn't matter. If I had another decimal there, we could move it once again. So it go from here to here. So that now is the non-calculator multiplication. So that one now is sorted. Let's go ahead and do that. So this is a typical 3-mark question in an exam. Okay, non-calculator division. Now often we use short division. So let's have a go at one with short division. Let's say I wanted now to divide, let's have 3 by 8. Okay, this we can use short division for and get a decimal answer. You might have learnt this as the bus stop method. The number in the denominator, which is the bottom of the fraction, goes on the outside. So the denominator of the fraction is 8. The numerator goes on the inside. And what I'm going to do is just put 3.0000. Okay, here's my first question. Does 8 go into 3? The answer is no, so we just put a 0 here. I'm now going to ask myself, does 8 go into 30? Yes, it does. 8, 16, 24. It goes in 3 times, and there is a remainder of 6. I now say to myself, does 8 go into 60? Yes, it does. It goes in 7 times. If I do 7 times by 8, that gives me 56. Or if you like, what is 60 divided by 8? The answer is it goes in 7 times and there's a remainder of 4. So all I'm going to do is put there's a remainder of 4. My next question is, does 8 go into 40? Yes, it does. It goes in exactly 5 times. We can see there's no remainder, so my division has ended. So 3 divided by 8 gives us 0.375. If you'd like to think about this now and look back at what I've just done, 3 over 8 is going to be half of 3/4. Now 3/4 is equal to 0.75, so as we would expect, 3 divided by 8 is going to be 0.375. Again, when you're doing your revision, have a calculator to hand. So that now is non-calculator short division. With both of these methods, it's just one of many different ways that you could do it. So we've done that one. Let's cross that one off. Okay, let's now move on and look at what we call place value. So let's write a number. If I wrote the number now 432.64, we might be asked to state the value of one of these numbers within this number. So for example, if I asked for the value now of the 3 in this number, we could say that this would be 30. This is now the hundreds column, this is the tens column, this is the units column, then we have tenths and 100ths. So the 3 we would write down 30. You could say it's now tens. I wouldn't like to write that. I'd like to write that it's 30. This one we could say that the value is going to be 2. So we're looking now at place value. Let's do another one. Let's say we've got 60,137.201, and we were asked to find now the value, or state the value of the 1. This is tens of thousands, so 10,000s. This is thousands, this is hundreds, and then we have the tens and the units. So 10,000s, thousands, hundreds, tens, units. So we could say now that the value of the 1 is 100. If we wanted the value of the 7, that is just 7, as they are units. So that's place value. In an exam, let's just move this on slightly. In an exam, often now they're doing questions, well, they've always done them. They will give you some calculation. So let's just do a calculation. Let's say 37 times by 123. So let's write this in. 37 times by 123. This isn't place value as such, but it's an interesting thing that we can look at this stage. This is going to give me now 4,551. The question will say, given that 37 times by 123 is 4,551, we might be asked, and it will say given, so you're not going to be doing any calculations. We would ask to now write down the value of 3.7 times by 123. We can see this number here has got 10 times smaller, so our answer is going to get 10 times smaller. So we'd have 455.1. Another example, we might have 37 multiplied now by 1.23. We can see now that this number has got 100 times smaller, therefore our final answer would get 100 times smaller. So we would, instead of having now the 51, we would end up, and let's just put that in, 45.51. Okay, let's just look at one more. Let's say we have now, we'll go for we'll say that this is going to become 0.37 multiplied by, let's go for 12.3. Okay, so we can see that this one has got 100 times smaller and this one has got 10 times smaller, so our answer is going to be 1,000 times smaller. So we're going to end up now with 4.551. Again, you can check this on a calculator. I strongly suggest that you do have a calculator to hand when you're doing revision. You certainly wouldn't get that in an exam, but we can see now that this just confirms what we're doing is correct. Okay, so that's place value. Let's move on and look at a square number. A square number, the easiest way to think about this now, if you're asked to list square numbers, let's go ahead now and draw a square. If we have a square and the side length is 1 and 1, the area is going to be 1 squared, which is 1. If we have a 2 by 2, so 2 by 2, that gives us 4. 1 and 4 are square numbers. If we had 3 times by 3, this would give us 9. 9 is a square number. So as you can see, we're just going to get them going upwards from here. So 16, 25, 36, 49, and so on and so forth. So a square number is a number, the same number, multiplied by itself. So if I wrote now 3 squared, this is 3 to the power of 2, which is equal to 3 times 3, which is equal to 9. A common misconception here is that 3 squared is 6, as people do 2 times 3. This is a massive pet hate of mine. So if we have 3 squared, that's what we end up with. Okay, let's now look at a square root. What this is the inverse operation. Now on Foundation, you're not really introduced to the fact that it might be a positive or negative answer, but we'll look at it anyway. So what I'm going to write is that 3 times 3 is equal to 9. So we know that's the case. So 3 squared is equal to 9. And I'm going to write therefore. This is a symbol for therefore. We certainly don't need to use it. It just makes things slightly easier. The square root of 9 is going to give us 3. Technically it gives us plus or minus 3, because if we have now minus 3 multiplied by minus 3, this also gives us 9. So all we're saying then is we're going to undo this. So which number, when multiplied by itself, gives us 9? The answer is 3. Okay, now again, going back to a typical exam style question. Recently, exam style questions have been coming up and they said approximate or find an approximate value of the root now of 41. And this would be on a non-calculator paper. Now if we think about this, we can work it logically. I know that the square root of 36 is going to be equal to 6. 6 times 6 is 36, so square root of 36 is 6. The square root of 49 is going to be 7, as 7 squared is 49. So our root 41 has got to be somewhere in the middle, so we'd say it's closer, slightly closer to 6, so at an educated guess, about, and this is a sign for about, approximately 6.5. So we can say now an approximate answer to the root of 41 is about 6.5. So let's go ahead and just tick these off. So a square number, it is the same number multiplied by itself to give us the answer. This is the square number, 4, 9, 16, 25 and so on. Square root is the inverse operation. So we're going backwards. Technically there's a plus or minus answer, but at Foundation you will generally not be penalised for not giving the negative answer. If you're doing higher maths, you will eventually get on to doing this, and for example, the root of 25 will give us plus or minus 5, and that's a nice way of writing it. We know that 5 squared is 25 and minus 5 squared is 25. Okay, let's look at a cube number. So a cube number, again, if I do a little diagram, you certainly don't need this, but it might give you some understanding. In fact, let's just go ahead and sketch this up. What we've got is a little cube. So let's say this is a cube. Now to work out the volume of a cube, we're simply going to multiply all of the side lengths. They will be the same. So there's my little cube. So we're going to have now 2, 2 and 2. To work out the volume, we multiply them. So 2 times by 2 times by 2. 2 times by 2 is 4, times by 2 is 8. We can say 2 cubed, or 2 to the power of 3, is equal to 8. It's not 6. Again, pet hate, 3 times 2 is, it seems that people want to do this. So 2 to the power of 3 is 8. It's 2 times by 2 times by 2. Whilst we're here, if we look at this base number, that is the number we're multiplying, and this power is the number of them we have. We have 1, 2, 3 of them. So for example, if I had 2 to the power of 4, this would be 2 times by 2 times by 2 times by 2, which is going to give us 16. We're multiplying the number 2 and we have 4 of them. Again, a pet hate is that someone would write 8. So that is a cube number. So if we look at 1 cubed, this is going to give us 1 times 1 times 1, which is 1. We've just seen that 2 cubed is going to give us 8. 3 cubed, all we would do is 3 times 3, which is 9, and times it by 3 again. So I'm just listing these out. 4 cubed is going to give us 64. 5 cubed would give us 125. And as you can see over time, you just memorize these. 216. Now, we could be asked to find the cube root. The square root looks something like this. The cube root, we would have a little 3. So if I ask for the cube root of 27, the answer would be 3. This is asking me which 3 numbers multiplied by themselves 3 times gives us 27. The cube root of 64 is going to give us 4. Remember, these are inverse operations. These don't have a plus or minus answer. As we might have, let's just say we had the cube root of minus 8. This would give us minus 2. And I'll let you work that out yourself. Okay, so that's what we have. So if we were asked now for an approximate value of the cube root of 31, then we could go ahead and look and say, well, the cube root of 27 is 3, so it's going to be somewhere just over 3. That brings us on, really, we will look later at, in terms of some indices or powers in the algebra section. But for now, I want to just focus, and we'll just put this one on, just focus on a couple of basics with powers. So if we look now at powers, let's say we've got, let's go for 5 to the power of 3. We've seen it just here. This is telling me to multiply the number 5, and I need 3 of them. So as we can see here, this is going to give us 125. 5 to the power of 4 is telling me I'm going to multiply the number 5. I need 4 of them. And this, of course, is just multiplying this by 5, which is 625. So don't fall into the trap of writing anything crazy. All we're doing is taking this number, the base, and we have the power. That's the number we're multiplying. That's how many we need. Okay, let's go ahead now and look at BODMAS or BIDMAS, or if you like, the order of operations. The way I like to see this is as follows. We have now brackets, and then we have O. O we can see as powers or roots. Then we have now, on the next level, division and multiplication. So division and multiplication. Then we have addition and subtraction. Before I go any further, I think it's important to say that if you go and scour the internet, you will find a range of different examples of how people disagree on certain ones of these. In GCSE Foundation, there's going to be none of those. We're just going to have basic examples. So we look for brackets, powers or roots, then we look for division, multiplication, addition and subtraction from left to right. So if I said 2 plus 4 times by 3. If we run down our list, we don't have any brackets, we don't have any indices or powers, we don't have any division, but we do have multiplication. Therefore, we do the multiplication first. I like to write this out step by step. So what we're going to have then is 2 plus 3 times by 4, which is 12. And of course, all we're left with now is addition. 2 plus 12 is 14. So that's going to be my final answer. It's not now going to be 18. People often add the 2 and the 4, then multiply by 3. So if we look at another one, let's say, for example, now we have 1 plus 2, and we're going to now square this, and then we're going to have now, and we will divide, in fact, let's multiply this by 3. No, we'll multiply it by 4. So let's do the brackets first. So 1 plus 2 is going to give me now 3. So we have 3 squared multiplied by 4. 3 squared is 9. Then 9 times by 4 is going to be 36. We'll do one more. Let's go ahead now and do, let's go for 8 divided by 4 plus now, let's go for 4. So on this one, we go down the checklist. No brackets, no indices or powers or roots. We do have division, so we're going to do the division first. So it becomes 8 divided by 4. 8 divided by 4 is going to give me 2. I then add the 4. 2 plus 4 is the only calculation we have left, and that's going to give me 6. So just read it from left to right and go ahead and write down now, step by step, what you're doing. In some questions, you might be asked to put brackets in to make the statement correct. If you do have that, just employ BODMAS or the order of operations. Okay, so that one's done. Order of operations is now done. So order of operations is now sorted. If you want this help sheet is on the site and you can grab yourself a copy. Okay, let's now look at the word integer. Integer is a whole number. The reason I've included this is because it crops up on lots of questions. So integers are whole numbers. 1, 2, 5, 20, 47. They're not fractions or decimals. So if we look at some examples of integers, let's go ahead and do that. Let's go that way. An integer. So integers now, and I'll write some out. So I'll write for I. We could have 10. We could have 24. We could have minus 5. We could have 16. A non-integer, and I'll just put it as ni, we might have 1/4. That is a fraction. It's not a whole number. We might have 0.67. That is not an integer. So integer simply means a whole number. Okay, a reciprocal. A reciprocal, we simply invert the fraction. So the reciprocal of 2/3 is equal to 3/2. So when we invert, we turn it upside down. If you like, it's the number we need to multiply our number by to get 1. So the reciprocal of 2/3 is 3/2. The reciprocal of 4 is going to be 1/4. We never write this as 4/1, but essentially that's what it is. So if I had the reciprocal, let's say now, of 7/5, the reciprocal is 5/7. If you multiply those two numbers, you're going to get 1. So that's what a reciprocal is. So we've done integers and we've done reciprocals. Okay, let's go ahead and do that. Okay, let's move on to rounding to 1 decimal place. Now, you might have to round to 2 decimal places or 1 decimal place, depending on the question. We'll do both. So let's take a number. Let's say we've got now 47.92. We want to round to 1 decimal place. If we're rounding to 1 decimal place, we're going to be rounding now to the nearest tenth. Or, if you like, this is the number that might possibly change. Okay, if I'm rounding this to 1 decimal place, I look at the number to the right. If this number is 5 or more, we would round up. If it's 4 or less, we would simply leave it as 0.9. So to one decimal place, this is 47.9. I'm not going to round that up as the number 2 is 4 or less. Let's look at 3.67. I want to round this number to one decimal place. This is the number that's going to change. I'm either going to have 3.6 or 3.7. The number after it is greater than 5, so we round up, and to one decimal place it's 3.7. So that's all we're doing. Okay, let's do one that's slightly more challenging. Let's say we've got now 41.97. Okay, so again, we're focusing on this number. If I look at this, we know we're going to round up. Now my choices to one decimal place are 41.9, or if I rounded up, it would be 42.0. We're going to need to round up as 7 is greater than 5, and as a result, we round now to 42.0. That is correct to one decimal place. Let's now look at two decimal places. Let's say I have 6.735. If we now look, the second decimal place is now, instead of the tenths, it's the hundredths. This is the number that could change. My choice is 6.73 or 6.74. This is to two decimal places. So do I need to round up? Well, the 5 now is 5 or more, so yes, we would. If I had 6.732, then again, we're focusing on whether this 3 is going to change. We would round down as the 2 is less than 5. So that's rounding to two decimal places. So if we had 40, let's say 40.127, we're going to now have to two decimal places. This is either going to be 40.12 or 40.13. We can see the number here is the one after the one that could change. This is greater than 5. In fact, let me just put that there to keep the continuity. We're looking at the number after the one that could change. We know that 7 is greater than 5, so we're going to round up. If it had been 40.121, we would have rounded down. So that is rounding to 1 and 2 decimal places. So that one now is sorted. Okay, let's move on and look at rounding to one significant figure. One significant figure can, of course, change. So let's have a look at some numbers. 424, 31.67, 2.03, 0.641, 0.0104. If I now go through and look at the first significant figure, it is the first figure or the first number when we read left to right that has a numeric value. So if we look, that is now the first significant figure in the number 424. So if we were rounding this now to one significant figure, we're rounding it to the nearest 100. This is the first significant figure in this number. This is tens, so if I was rounding to one significant figure, I'd round to the nearest 10. Here, the 2 is a unit, so the first significant figure is a 2. When we're talking about significant figures, it's the first non-zero number. So this is not significant. The first significant figure in this number is the 6, and that is tenths. These are tenths. So we'll be rounding to the nearest tenth. Here, the first significant figure is the 1, and that is 100ths. If we see a 0 after, we don't worry. Once we've got one value, all of these become significant. So let's go ahead and round each of these to one significant figure. My choices on the first one are going to be 400 or 500. We're rounding to the nearest 100. That is the first significant figure. I can see that I've got a 2 after it, so we would round down. The next one to one significant figure, remember we're rounding to the nearest 10 as the 3 is in the 10 column. We'd have 30 or 40. Again, the 1 after it, we would round down. This one to one significant figure. These are units. We have the choice now of 2 or 3. The 0 after says I'm going to round down again. If we look at this one, to one significant figure, we're rounding to the nearest 10th, 0.6 or 0.7. Again, the 4 comes after the 6, so it will round down. The next one, we're rounding to the nearest 100th, 0.01 or 0.02. Again, the 0 means that we're going to round down. So in all these cases, we've rounded down. Now, if we were looking at this and we were asked to round these to two significant figures, this is the second significant figure in this number. They are going to be now the tens. If we were rounding this number to two significant figures, we would be rounding to the nearest unit. If we were rounding this number to two significant figures, we would round it to the nearest 10. With this one, it would be to the nearest 100. And with this one, it would be to the nearest 1000. So let's just quickly do the first one. So I want to round this, and we'll take this number here, to the nearest 10. So my choices are 420 or 430. We've got the 4, so we're going to round down. So to 2, this is to 1 SF, so one significant figure. This now is to two significant figures. This one we would round to the nearest unit. My choices are 31 or 32. We got a 6 afterwards, so we're going to round up. This one we would either round to 2.0 or 2.1. We can see that 3 is going to be less, so it's 2.0. With this one, 0.64 or 0.65, correct to two significant figures, it would be 0.64. This one, 0.010 or 0.011. It would be 10 as we've got a 4. So that now is looking at rounding to 1 and 2 significant figures. In the exam, generally on the foundation, it will be one significant figure. So look at your number and say, what now is the first significant figure? The first significant figure are hundreds. It's tens, it's units, it's tenths, it's 100ths. Okay, let's go on and look at multiplying and dividing negative numbers. Okay, let's just build some rules up. If the signs are the same, the answer is going to be positive. So if we have a positive multiplied by a positive, we end up with a positive answer. If we have a negative multiplied by a negative, we end up with a positive answer. I'm going to bracket these off. If the signs are the same, we're going to end up with a positive number. If they're different, we're going to end up with a negative number. So if we have multiplied by a positive, this too gives us a negative. So let's start off with something absolutely basic. 2 times by 4. Both of these are positive, as I'm not told otherwise. If we don't have a sign, we assume they're positive. So that's going to be 8. Now if I had minus 2 times by 4, I've got one negative and one positive, so my answer is going to be the same number but negative. If I had negative 2 or minus 2 times by minus 4, let's write that there, I've got 2 negatives, that's going to give me a positive. If I had 2 times by minus 4, this one is positive, this one is negative, so our answer is going to be negative. The same goes with division. So if we were doing, for example, let's do 10 divided by 2, we know the answer is going to be 5. If we had minus 10 divided by 2, this is going to give us minus 5, as 1 is positive and 1 is negative. Same goes, minus 10 divided by minus 2 will give us positive 5. So your take-home message is, if the signs are the same when multiplying or dividing, your answer will be positive. So that one is sorted. So multiplying and dividing, if the number now, if the signs are the same, is positive. If they're different, it's negative. And just remember, we don't have a sign here, so we assume this to be positive and positive. Right, let's move on now to look at adding and subtracting negative numbers. Okay, now this causes some confusion. Let's just look at some examples. If we have now 2 minus 1, we know quite clearly that this is going to be 1. If we have 2 minus 1, we're going to end up with 3. If we subtract a negative number, in essence, we're adding it. So 2 minus 1 becomes 3. Okay, let's try another one. Let's do 4 minus 3. 4 minus 3 again gives us 1. 4 minus 3, we have minus and minus, we're going to add it, and that's going to give us 7. The way I like to think about this is, where are we starting on the number line and where are we going? So let's try a harder one. We're going to do minus 1 minus 4. Now, this is where we're starting on the number line. We're starting at minus 1 and we're subtracting 4. If I do that, I'm going to go down to minus 5. Remember, this essentially is saying we're going to be subtracting a positive number. Yet if I did minus 1 minus 4, we start at minus 1 on the number line, we add 4, and that takes us up to positive 3. So if I had minus 10 minus 6, the answer would be minus 16. Yet if I had minus 10 minus 6, I would end up with minus 4. As I'm adding 6, I'm getting 6 closer to 0. So this is where we're starting on the number line. This is telling me what I'm doing, and this is the type of number that we've got. So just here, some examples. 2 minus 4 is minus 2. Yet if it was 2 minus 4, it would be 2 plus 4, which would give us 6. 3 minus 5 is 8 as we're adding it on. If it had been 3 minus 5, it would be minus 2. Minus 2 plus minus 5 is minus 7. We start at minus 2 on the number line and we go backwards. If you want a number line, you can do. And for example, this one right here. So let's just look at this one. This is going to be 0. So let's go for minus 2 here. So we start at minus 2 and we're going to go back now by 5. So this is going to be subtracting 5, which gives us minus 7. Yet if we went ahead, and let's go ahead and do that, looks something like so. If we now subtracted minus 5, we would be adding that and we would go to 3. So adding and subtracting negative numbers. Okay, let's go ahead now and cross that one off. So we've done that one. Let's move on and just briefly just going through these. We've got the next one to look at. So we've just looked at negative numbers. Okay, let's now move on to estimations and approximations. Now, generally speaking, we round our answer to one significant figure, or our two values, and then multiply. So let's look at an example. Let's say I had 9.8 times by, now let's go for 3.1. I want to be in a shop and I want an approximate value for this, okay? Now, an approximate value is one that I can work out in my head. I don't want any decimals, so all I'm going to do is round each of these to one significant figure. So this number to one significant figure, remember, it's either going to be 9 or 10. We would simply round to 10. This number to one significant figure is either going to be 3 or 4. It's going to be 3. 10 times by 3 gives me 30. That is an approximation. So all you're doing is estimating an answer. You don't have to do anything crazy. You simply need to give a logical, off the top of your head answer. So let's say we had now, let's go for 47 times by, and let's go for, we'll go for 2.3. So to one significant figure, I've got a choice of 40 or 50. I'm going to take 50 as the 7 is greater than 5. And to one significant figure, this is either 2 or 3. The answer is going to be 2 as 3 is going to be less than 5. So an approximation is going to be 100. Okay, let's look at those tough type of questions that come up in exams that students often struggle with. So let's do now, we'll do 12.3 times by 4.7 divided by 0.48. Okay, this now we would want an approximate value for. So let's round these now to one significant figure. 12.3 to one significant figure is going to be 10. 4.7 to one significant figure is going to be 5. 0.48 to one significant figure is 0.5. So what we have is 50 divided by 1/2. And this now is where lots of pupils make errors. How many halves go into 50? The answer is 100. If we're dividing by half, we're multiplying by 2. Often students write 25 at this point. But again, it's just now 50 divided by half. And that is a typical question that is often answered incorrectly. So estimations and approximations, we round to one significant figure. It's the kind of thing that we'd want to do if we were at now in a shop buying 10 or 9.8 times by 3.1. We just want a figure off the top of our head. Okay, let's now look at the factors of a number. So let's start with a number. The factors of a number are all of the numbers that go into that number exactly. So let's start now with the number 10. I'm going to look at the factors of 10. The way I like to do this, rightly or wrongly, is say, can I multiply 1 by something? The answer is yes, 1 times 10. Can I multiply 2 by anything? Yes, I can, 2 times by 5. What about 3? What about 4? And then, of course, I'm back on to 5. So all I'm looking at now are the numbers I can multiply to get 10. Alternatively, you can go the other way and say, can I divide 10 by 1? Yes, the answer is 10. Can I divide 10 by 2? Yes, the answer is 5. Can I divide 10 by 3 and get an integer or whole number answer? The answer is no. Then, of course, we try 4, no, and then we're back on 5. Therefore, all I'm going to do is read the numbers. So the factors of 10 are going to be 1, 2, 5, and 10. If we now look at the factors of 16, I can have 1 times by 16, I can have 2 times by 8, I can't have 3 times anything as 16 doesn't divide by 3, I can have 4 times by 4, 5 I can't divide 16 by 5, that gives me 3.2, and I can't divide it by 6, I can't divide it by 7, I can divide it by 8, but we're back onto ourselves. If you just look at this, this makes fairly straightforward sense that if I can divide it by 8 to get 2, well, if I divide it by 2, I get 8. So these are the ones we're interested in. In ascending order, which means from smallest to largest or getting bigger, 1, 2, 4, 8, and 16. So these are the factors of 16. Okay. Next one we're going to look at is the product of prime factors. Every number can be written as a product of prime numbers. Now, when you see product of prime factors, think factor tree. I'm going to write down the prime numbers here. The prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, and so on and so forth. You shouldn't have to go much further than this. So let's define a prime number. A prime number is a number that can only be divided by itself and 1. Technically that's incorrect, but we can see it as one way of looking at it. They must have two factors. That's why 1 is not a prime number. So 2 now is the first prime number because we have 1 times 2. Let's just write this here. 1 times 2. So we've got 2 factors and now one of them is 1. If we look at 3, that's just going to be 1 times 3. Yet with 1 is not a prime number because there's only one factor to it. So if you want a prime number, is a number that can only be divided by itself and 1. So what we're going to look at then is product of prime factors. I'm going to take now the number 12. We're going to write 12 as a product of its prime factors. My first question is, can I divide it by the first prime number of 2? The answer is yes. That's going to now leave me with 3. Okay, so that's going to leave me with 6. Can I divide 6 by the first prime number, which is going to be 2? Yes, I can. And that leaves me with 3. 3 is a prime number, and all I'm doing is circling the prime numbers. So it becomes 2 times by 2 times by 3. So 2 times by 2 times by 3, or if you like, 2 squared times by 3. That is writing 12 as a product. Product means multiply. Prime means the prime numbers. Factors just mean the numbers that go into 12. So let's try 27. Can I divide this by 2? The answer is no, so I try and divide it by 3. I can divide it by 3, which is going to give me 9. Can I divide 9 by 2? No. Can I divide it by 3? Yes, I can. That's going to give me 3. We're left with 3, and we now have 27 as a product of prime factors. 3 times by 3 times by 3, or 3 to the power, I don't know why I've got 2 to the power of 4 there, it should be 2 to the power of 2, 3 to the power of 3, and we've seen that before, it's 3 cubed. So, product of prime factors. Let's do one more, let's do 42. Can I divide this by 2? The answer is yes. That's going to give me 21. Can I divide 21 by 2? No, so I need to divide this by 3. If I divide this by 3, I'm going to end up with 7. 7 is a prime number, so as a product of prime factors, 2 times 3 times 7. And that's what we'd write now as our answer. So when you see product of prime factors, think factor tree. Okay, so that one is done. So product of prime factors. Okay, let's go on and look at the highest common factor. The highest common factor is the biggest number or the largest number that goes into at least 2 given numbers. So HCF, highest common factor. Let's now look at the numbers, and we're going to go for, let's go for 6, and we will go for 8. So nice and straightforward to begin with. On Foundation, I'm going to give you a nice straightforward way of doing this. What we're going to do is look at the factors of the smaller number first. So if we think about the factors of 6, we're going to have 1, 2, 3, and 6. I say to myself, now, does 6 go into 8? The answer is no. Does 3 go into 8? The answer is no. 2 does. So the highest common factor of 6 and 8 is 2. We could have listed out the factors of 8, 1, 2, 4, and 8, and looked along the list at now the largest number that's in both lists. So that's the highest common factor. So let's go for, we will go for 6 and, no, we'll change them over. Let's go for now 4, and then we will go for 14. So if I look at 4, I'm going to have the factors of 1, 2, and 4. If I look at the factors of 14, 1, 2, we will have 7 and 14. So we can see now that, again, the highest common factor is going to be 2. It's the largest number that goes into both of these numbers. If we had now, let's go for something else. Let's say we've got 8 and we've got let's go for 20. So with 8, 1, 2, 4 and 8. Now straight off you could say, does 8 go into 20? The answer is no. Does 4? Yes it does. So that's the highest common factor. Alternatively, you could have done 1, 2, 4, 5, then we would have had 10 and 20. They are the factors of 20, and we can see that's the highest common factor. So the highest common factor is the largest number that goes into both. If you're going on to higher, you can use the product of prime factors and look at the powers for more advanced cases, but in terms of GCSE Foundation, list out the factors and then see which is the largest number that goes into both. Okay, let's look now at the lowest common multiple. The lowest common multiple is the first number that 2 or more numbers go into. So let's have a look at a nice straightforward example. Let's find the lowest common multiple of 6 and 8. All I want to do is find the first number that both of these go into. So let's have a look at 6. The 6 times table will give me 6, 12, 18, 24, 30, 36. The 8 times table, 8, 16, 24, 32, 40 and so on and so forth. Straight off we can see the first number they both go into is 24. So all I'm going to do is write now that the lowest common multiple, the first number that both of these go into, is 24. If you want to list out the multiples of the large number and just say to yourself, does the smaller one go into that? You can do. I'm not really hugely fussed. Entirely up to you. So lowest common multiple, list out the times table and see which is the first one that they go into. Now sometimes, and you just have to be a little careful, for example now if we had 3 and 5, we can see now that the lowest common multiple is going to be now 15. It's multiplying these two. But right here, if we'd done that, we would have had 48, which is not correct. So yes, the lowest common multiple is often when you multiply the two numbers, but not always. So if we look at this one, we'd have 3, 6, 9, 12, 15, 18. This one we'd have 5, 10, 15, 20. We can clearly see lowest common multiple is 15. Again, if you do that with 2 and 4, you're going to get the lowest common multiple is 8, but of course it's 2. Sorry, it's 4. Yeah, it's 4. So lowest common multiple, first number 2 or more go into. Okay, let's move on and look at simplifying fractions. So simplifying fractions. So let's say we had now, let's go for 5 over 10. I'm looking for a number that I can divide the numerator. Remember, the numerator is the top and the denominator by. Denominator is the bottom. So what number goes into both of these? Well, we can see quite clearly 5 goes into both. So if we divide the top by 5 and divide the bottom by 5, an equivalent fraction is going to be 1/2. That is what we call an equivalent fraction, and we've simplified. Now, if we were asked for an equivalent fraction here, we could say, well, that's going to be 10 over 20. We could say it's 100 over 200. So these are all equivalent fractions. They have the same value. Let's look at another one. If we had now 7 over 21, we can see that this will divide by 7 in the numerator and the denominator, which would give me 1 over 3. If we had, for example, now 6 over 8, we can divide the numerator and the denominator by 2, and that would give me 3 over 4. I can't simplify this any further. 3 is a prime number, and we can see that's in its lowest form or simplest terms. If we were asked for an equivalent fraction, we could now do anything with this as long as we're consistent in terms of multiplication or division. So we could have 60 over 80. We could have 12 over, now just multiplying this up, 12 over 16. So all I'm doing is giving equivalent fractions. Now, if you're faced with something like this, the first thing I would do to fully simplify this fraction is divide the numerator and the denominator by 10. We can cancel a 0 in the numerator and denominator if we're dividing by 10. So, for example, if you had 600 over 800, I'd write it as 6 over 8 and then simplify from there. So that's simplifying fractions. You might have mixed numbers to deal with and turn them into top-heavy fractions. So, for example, now if we had, let's look at some mixed numbers and top-heavy fractions. So if we had 2 1/4, this is a mixed number, this is an integer, and this is a fraction. If we wanted to write this as a fraction, and we would call this an improper fraction, a top-heavy fraction, or a vulgar fraction, all I'm going to think to myself is how many quarters are there in 2? And we can find that by multiplying these two numbers. So what I'd have is 8 over 4 plus 1 over 4, which is going to give me 9 over 4. So as a top-heavy, improper or vulgar fraction, 2 1/4 is 9 over 4. If we had 3 2/5, I could say to myself, well, 3 times by 5 is 15. So I'd have 15 over 5. That now is 3 plus 2 over 5, which is going to give me 17 over 5. So that's switching now a mixed number into a top-heavy fraction. We can, of course, go the other way. Let's say we wanted to switch up now, and let's say we had 14/5, and we wanted to put this as a mixed number. Now I can see that 5 goes into 14 twice. So what I could write now is that I'd have 2 whole ones, and then I'd have 4/5 remaining. So if you like, you could write this now, if you really wanted to split it up, you could write it as 10 over 5 plus 4 over 5. We know that 10 over 5 is 2, so we'd have 2 4/5. Again, if you want to check it, 2 times 5 is 10, plus 4, we would have now 14 over 5. Let's just do one more. Let's say we've got now, and we'll do 16/7 as a mixed number. So again, 7 will go in twice, and that will leave me a remainder of 2. So it'll be 2 2/7. So that now is looking at simplifying fractions. Okay, let's move on and look at finding a fraction of a quantity. So let's start with some nice straightforward non-calculator examples. Let's find 1/5 of 20. Of means multiply. So 1/5 of 20. All we do is do 20 divided by 5. 20 divided by 5 will give me 4. Therefore, if I had 2/5 of 20, 2/5 of 20, I'm going to now simply multiply this answer by 2, and that would give me 8. 3/5 of 20, we find 1/5, and then multiply our answer by 3, and that would give me 12. If we look at 4/5 of 20, so 4/5 of 20, we're going to end up with 16, and quite clearly 5/5 of 20 is going to be 20, as 5/5 is just 1. So that is how we can work this out. Now sometimes you won't have that luxury of being able to do this now in terms of non-calculator. But if we wanted to find, for example, 3/7 of, let's say, 36.94, in the calculator we can simply type it in. So what I'm going to do is get my fraction button, 3 over 7, and when we're talking about of, we're talking multiplication. Of means multiply. So all I'm going to do is do that, and that gives me, pressing my S to D button, 15.8, and that's correct to 1 decimal place. So 15.8, and I'm just going to write 1 decimal place. Okay, so that's how we do it. So if you wanted to find, for example, 2/9 of 72.4, just type it in the calculator. Or you could divide this number by 7 if you've not got a calculator like that, or you're not happy, and then go ahead and multiply. So that's looking at finding a fraction of a quantity. Okay, let's go ahead now and look at, on the next one, ordering fractions. Okay, now ordering fractions. Let's just do a quick example. This is a typical exam style question. Now if I had, let's take something nice and straightforward. If I had 1 over 7, I had 5 over 7, I had 3 over 7, and I had 2 over 7. The denominators are all the same. So all we're interested in now is the numeric value of the numerator. So this would now be the smallest, this would be the second smallest, this would be the third smallest, and this would be the largest. So in ascending order, remember ascending is going up, descending is going down. So if you ascend a mountain, you go from the bottom to the top, or the smallest to the largest. If you descend, you go from the largest to the smallest. It's like in a lift. You descend in a lift. Okay, so that was fairly straightforward. Let's look at a different example, and we're going to order some fractions. Let's look at 1/4. Then we'll have now, let's go for 7/12. Let's go for 2/3. And let's go for 5 over 6. What I'm going to do here is write these all as equivalent fractions. So when we write them as equivalent fractions, we look for the lowest common multiple of the denominator. So what are the denominators? What can I turn all of these into? The answer is 12s. 4, 12, 3 and 6 all go into 12s. So with this one, I'm going to now turn this into 12s. I need to multiply this number by 3, therefore I need to do the same here. So as an equivalent fraction, 1/4 is 3/12. 7/12 is already in 12s. I need to multiply the 3 by 4, so I need to multiply the 2 by 4. So I get 8/12. I need to multiply the 6 by 2, so I need to multiply the 5 by 2. So we can see now that we have all of these in 12s, and they are actually in order. 3, 7, 8, 10, all over the same denominator. So what we do is write that this one is the smallest, this one is the second smallest, third smallest, and then the largest. We wouldn't give our answer like this, we would give it like so. So just make sure you're putting them back. Okay, let's do one more. Let's do 0.25. Let's do now 1/3. Let's go for 0.67. Let's go for, we'll do now, let's go for 24%. Okay, with a question like this, it's entirely up to you on how you want to do it. If you're comfortable, you can switch them into fractions. If not, you can switch them into decimals. If not, you can switch them into percentages. So you decide what you're most comfortable with. I'm going to rewrite this, and what we're going to have is in decimal form 0.25. Now 1/3 is 0.3 recurring. 0.3333. One major error is people put 0.3, or if they say it's 0.3, it's 0.3 recurring. If you split a pound between 3 people, they're going to get 33.333p. Okay, so next one, 0.67. If we want to now convert a percentage to a decimal, we simply divide by 100, so this will give me 0.24. We can now compare these. And again, if you don't see this, you can put them in hundreds, tens, units column. So 0.24, 0.25, we've got 0.3 recurring, which is 33333, and then we got 0.67. So I've put them in order. If you want to put them in the order that you see them, we can see now that the value of the tenths is increasing, and then we consider a 4 is less than the 5. So now this would be the smallest, this would be the second smallest, the third smallest, and then the largest. So that's ordering fractions, and then I've looked at ordering some decimals and switching things up a little. Okay, let's now look at adding fractions. Okay, when we're adding or subtracting fractions, the denominators must be the same. So if I have now, let's say I've got 1/4. Let's say I've got 1/4 plus 1/4. The denominators are the same. I simply need to add the numerators. That will give me 2/4, which we could simplify to as 1/2. Although mathematicians dislike this idea, just think about it as a pizza. If you've got now a pizza, and we'll just put this on, and you go ahead and cut this up, if I now think about this, I'm going to add 2/4. So we're cutting this into 4 bits. So that is 1/4, that is 1/4, that is 1/4. So if I take 1/4 and I add it to another quarter, I have 2/4. I don't have 2/8, which is a common misconception. We're only adding the tops, not the bottoms. We can see 2/4, which quite clearly is going to give us 1/2 as a simplified fraction. So if we had now, and we'll do adding and subtracting fractions together, exactly the same, we're just going to be using a slightly, well, we're going to be subtracting instead of adding. So if I had now 5/7 minus 2/7, then the denominators are the same. We can simply subtract the numerators, which would give me 3/7. Again, you could see it with your pizza. If you had 3/4 and you took away 1/4, then you're going to have 2/4, which is 1/2. So when we're adding or subtracting fractions, if the denominators are the same, we simply either add the numerators when adding or subtract them if subtracting. Okay, let's start looking at when the denominators are different. What I'm going to do is write 1/4 plus 1/8. We have now different denominators. We must make the denominators the same. Often people cross multiply. I don't like to cross multiply. I like to find equivalent fractions. The reason in this case I wouldn't want to cross multiply is because we'd end up with 32. We'd have 8/32 plus 4/32. Let's think of an equivalent fraction that we could write 1/4 as. Now I know that 4 goes into 8. So what I'm going to have then is 2/8 plus 1/8. This is an equivalent fraction. So 2/8 is 1/4, 1/8, which is what we were given. The denominators are the same, so we simply add the numerators, and the answer is 3/8. So if we had, for example, let's say we've got 2/5 plus 3/10, then we can see now that 10, we can write the fifths as tenths as now an equivalent fraction. So we multiply this one by 2, we multiply that one by 2. So as an equivalent fraction, that is 4/10 plus 3/10, which is going to give me 7/10. If you wanted to then, if you're asked to write that as a decimal, 7/10 is 0.7. We're not asked to do that. That was just something additional. Okay, let's go ahead now and do, let's say we've got, we will go for 9/14, and we will subtract away now 1/7. In fact, we'll make this 2/7. Let's make this slightly more interesting. Okay, so I know that 7 goes into 14, so I'm just going to write an equivalent fraction to get common denominators. So this is going to be minus 4/14. We're subtracting, so we simply subtract now the numerators. So we get 5/14. So that worked out quite nice. Let's now try 2/3 plus 3/5. Now at this stage, some people cross multiply. That's perfectly fine. If you want to multiply all of this side of a fraction by 5 and all of this side of a fraction by 3, you can do. I prefer to think again about equivalent fractions. The lowest common multiple of 3 and 5 is 15. So I can switch these up into 15s. This would give me 10/15. This is going to give me 9/15. Once I have that, I can simply add the numerators. So I've looked at equivalent fractions. You can, of course, just multiply all of this fraction by the denominator here and multiply all of this fraction by the denominator here. It will give you the same result eventually. Sometimes you'll need to break them down beforehand, especially if you did it with this one, because you'd multiply all of this fraction by 8 and all of this 1 by 4, which would give you now in total 8 over 32 plus 4 over 32, which is going to give us now 12 over 32, which we would need to go ahead and simplify further. So entirely up to you. So all I'm going to do is add the numerators, which gives me 19 over 15. This is a top-heavy fraction, or improper, or, if you like, vulgar. So we could write this as 1 whole 1 and 4 15ths, as we looked at very recently. So that now is what we would have. So that's adding fractions with different denominators. Again, we could do this with subtraction. So let's look at an example with subtraction. So what I'm going to do now, I will do a slightly harder one. We will do 5 over 6 minus, and we'll go for 3 over 8. So let's think about now the lowest common multiple. What's the first number that 6 and 8 go into? The answer is 24. So what I'm going to do is now write these as 24ths. So if you think, we go 6, 12, 18, 24. We go 8, we go 16, we go 24. That's the first number they go to. You're more than welcome to multiply this side by 8 and this side by 6 and then simplify. Entirely up to you. So if I wrote this now, this would be 20 over 24, as I've multiplied the numerator and denominator by 4 to get up to 24. This one I would have now 9 over 24, as I'm going to multiply numerator and denominator by 3. So all I'm left to do is subtract the numerators, and that gives me 11 over 24. So that's done. Let's just look at a mixed number. Let's say we've got 1 and let's go for that. We will do 1 and a third. So let's do 1 and a third. So 1 and 1/3 plus 2, and let's go for 2 and 5 over 6. So with this one, what I like to do is add the numerators. So we're adding the numerators. So 1 and 2 is going to give me 3. So I'm first going to write that I'm going to have 3. And then I'm going to have now a third plus now 5 sixths. So if I do 1/3, let's just write this here, 1/3 plus 5 over 6. I could write this as 2 over 6. So 2 over 6 plus 5 over 6. That would give me now 7 over 6. Or we could say 1 and 1/6. So my final answer would be 3 plus 1 and 1/6, which would give me 4 and 1/6. Let's write 6 rather than 16. 4 and 1/6. So that's what we get. Now, you could have argued that you're going to convert these into top-heavy fractions if you want. So if you did that, we would have now 3 over 3 plus 1 over 3, which is 4 over 3, plus now 6 times by 2 is 12, add the 5, plus 17 over 6. We could write this now as 12, so just multiplying this up, what have we got? Going to double that up. So we'd have 8 over 6 plus 17 over 6, which is going to give me 25 over 6. 6 goes in 4 times, so we'd have 4 whole ones and 1 over 6. And that gives us the same answer. So adding and subtracting fractions, and we've also looked at some mixed numbers. Okay, let's move on and look at multiplying fractions. When we're multiplying fractions, we don't need a common denominator. The same goes with the division of fractions. When we're multiplying fractions, we multiply the numerators and multiply the denominators. So let's look at 4 over 5 multiplied by 3 over 7. 4 times by 3 is 12. 5 times by 7 is 35. Do check that you can't simplify. Multiply the numerators, multiply the denominators. So let's say we have now 1, let's go for 1/6 multiplied by 4, and we'll go for, let's go for 4/9. Now at this stage, you could cancel off diagonally. I'm going to suggest you simply multiply and then break the fraction down. So we're going to end up with 1 times 4 is 4, 6 times by 9 is 54. I look and think, well, I can divide these both by at least 2, so I'm going to do that. That would leave me now 2 over 27, and that would be my final answer. So all I've done is multiplied the numerators, multiplied the denominators, and then simplified. What you could have done here, and this is if you do take your studies on, we can divide either vertically or diagonally. So I can divide at this stage and write that this is going to be 2 and this is going to be 3. 1 times 2, 3 times 9, and we could do that. On Foundation, I think just multiplying and then simplifying is ideal. Okay, so the next one we're going to look at, and we'll just cross this one off, is dividing fractions. Okay, dividing fractions, a nice little, well, something to remember, we turn and times. I like TNT, so turn and times. Now, if I have, let's say, 4 over 7 divided by, let's say, 3 over 5, this is the same as 4 over 7 multiplied by the reciprocal. Remember, the reciprocal is just now 1 over this value. So all we're doing is turning and timesing. We turn the second fraction and multiply. So this is going to give me 20 over 21, and we can't break that down anymore. So if we did 1/5 divided by 4/9, then this would be the same as 1/5 multiplied by 9 over 4, and that would give me 1 times 9 is 9, 4 times 5 or 5 times 4 is 20. Turn and times. You divide now by simply multiplying by the reciprocal. Turn the second fraction round and then multiply. Only turn the second fraction round, and that should be relatively straightforward. You will have to remember that, but it's really important. And that goes back to that question we looked at. If we have now 50 divided by 0.5, we could write this as 50 divided by 1/2, which is the same as 50 multiplied by 2 over 1. And of course, 2 over 1 is just 2, and that gives us 100. So that was the one we looked at before, and hopefully that makes some sense. So dividing fractions. Okay, let's go ahead and look at the next one. Writing a number as a percentage of another. Okay, I like to think about this as a test score. Let's write now, and we'll go for 7, and we'll start with non-calculator ones. We'll write now 7 out of 10. So 7 of 10 as now a percentage. All we need to do here is write that it's 7 over 10. Now, percentage means out of 100. So what would I have to do to turn the denominator of this fraction into 100? The answer is multiply by 10. Therefore, if I'm going to multiply the numerator by 10, the denominator, I need to multiply the numerator by 10. 70 out of 100 is 70%, 70 per 100. So if we had, for example, let's say we've got 9 of 20. What do I need to do here? Well, I know that 20 goes into 100 5 times, so I need to multiply the numerator and denominator by 5. So 20 goes in 5 times, so that's going to give me 45 over 100, which is 45%. Let's look at a slightly more challenging one. Let's say we've got, let's go for 12 out of 40. We want to write this as a percent. So writing another number, or a number as a percentage of another. I want 12 as a percentage of 40. Okay, now with this one, I'm going to say to myself, what would I need to do to get this to 100? The answer is multiply by 2.5, but that might not be obvious. So instead, what I'm going to do, and I've got a couple of choices, I'm going to half this. So I'm going to have 6 over 20. When I say half it, I don't mean half the value of the fraction, I just mean half each value. So I know that I need to multiply each of these now by 5 to get up to 100. So that would give me 30 out of 100, which is equal to 30%. You could have said, well, in fact, we'll divide this by 4. So that would have given me 3 out of 10, which is the same as 30 out of 100, equivalent fraction, which of course is 30%. So there we go, nice and straightforward. Now, what about if this was messy? Let's say we've got 16 out of 37. We wouldn't know how to do this. All we're going to do is set this up on a calculator. So I'm going to have now 16. So I'm writing 16 as a percentage of 37. 16 over 37 times by 100, and that will do it. So 16 of 37. This is essentially all we've done here. So that's going to give me 43.2%, and that is correct to 1 decimal place. So if I wanted, let's say I got 9 out of 20, let's go for 23 in the test, and I wanted to know what percentage that was, the answer is going to be now 39% to the nearest 1%. Okay, so that's that one. Okay, let's cross that one off. So writing a number is a percentage of a number. Okay, we're now going to find 10%, 5% and 1% of the quantity non-calculator. Let's start now with £54, or just the number 54. So if I start with the number 54, this is everything of a number. It's 100% of a number. Okay. Now, if I want to find 10%, I'm going to divide this number by 10. So 10% of 54, let's just write this here, 10% of 54 is going to be 54 divided by 10, which is 5.4. If I wanted 1% now, I can simply divide this by 10 again, or I can say I'm going to divide the original number by 100. This would give me 0.54. So all I'm doing is dividing this one by 10 or this one by 100. Now 5% must be half of 10%. I've already got my 10%. Half of 5.4 is 2.7. So if we're asked to find, for example, 23% of £54, just writing this in, £54 without a calculator, we can do two lots of 10%, and then we can add to that 3 lots of 1%. So if I do now two lots of 10%, that's going to give me 10.8. If I do 3 lots of that, that's going, this one right here, that's going to give me 1.62. So 1.62. So all I'm doing is working this out, and we can go ahead and add those. So what does that look like? £12.42. Again, you can check that if you want on a calculator. So if you wanted, you could do 23% of 54. So let's go ahead and do that. Let's do 0.23. So 0.23, in fact, let's just do it like this. 0.23 times by 54, and that's going to give me my value. Oh, don't want that one. Let's see if we've got that. So let's do that again, getting a bit lazy. 0.23 times by 54. Remember, 0.23 is 23% as a fraction. So that gives us the £12.42. We do 2 lots of 10% and 3 lots of 1%. You could have divided this by 4 and then taken away 2%. So this is how we can build them up. So for example, 16%, we could have now with this one 10%, we could have 5%, and we could have 1%, and then add it up. So that's nice and straightforward. So that brings us on to this, increasing or decreasing a number by a percentage. So if we wanted to now increase, let's say we wanted to increase £30 by, let's say, by 11%. Let's make this slightly harder, okay? What we're going to do, without a calculator, we're going to have now the following. So I'm going to say now that 10% will be equal to £3. So 3.00. 1% is going to be equal to, dividing this by 10, 0.30. So that gives me that 11% is going to be equal to £3.30. and all I need to do is add that on. So we're going to have £33.30. I've increased £30 by 11%. I found 10%, I found 1%, and I've added it on. If it asks us to decrease, for example, by 2%, let's decrease that. So we can say now, let's go for decrease. So decrease £30 by, let's go for 2%. Well, 1% now is going to be 0.30, so 2% is going to be 0.60 or 60p, if you like. I'm keeping my units the same, but it's entirely up to you. So our answer is going to be now £29.40 as we're subtracting it, we're decreasing it from that value. Okay, now increasing and decreasing, you could look at a table of multipliers, especially if it's non-calculator. So if it is calculator, if I multiply anything by 1.0, that will give me 100%. It will give me everything. If I multiply it now by 1.01, this is going to be 101% of the original, or a 1% increase. So 1% increase. If I look at multiplying by 1.02, this is going to give me a 2% increase. Students often confuse these. I'm going to do and miss out a few. 1.1 or 1.10 is going to give me a 10% increase. So if we wanted to now, if I was doing this on a calculator, my multiple now would be multiplied by 1.11, and that's going to give me an 11% increase. So if this was a calculator question, all I do is go ahead and do now 30 and multiply it by 1.11. That's 111%, and that will give me my £33.30. You could see this as 30 times by 111%. So if we do that, let's put that in, that will give us exactly the same. So if we're decreasing, we can say multiplying by 0.99 is equal to 99% of the original, which is going to be a 1% decrease. If I multiply it by 0.98, that's going to be 98% of the original value, or a decrease of 2%. And again, another one students often make the error on, it's going to be 0.90. This is a 10% decrease, or 90% of the original. So that's a 10% decrease. Again, one that people seem to struggle with, let's have 0.2. 0.2 is 20. 0.02 is 2. So now, just be a bit careful. If you want 2% of something, it's 0.02. If you want 20%, now it's 0.20. So let's just put this in. This is 20% of the original. This is 2% of the original. So this is a 98% reduction, and this is an 80% reduction. So there we go. That's increasing and decreasing. So we've got finding the percentage of quantity, non-calculator and calculator, and increasing and decreasing a number by a percentage with both calculator and non-calculator. Okay, let's move on and look at fractions to decimals. So fractions to decimals. Some of these are obvious and ones that you should just know. So if we look at a fraction now, if I had 1/4, this as a decimal will be equal to 0.25. So there are some that you should know. Now, if I said what about 1/8, this is one that you might not know as much, but if you think about it, it's just going to be a half of a quarter. So 0.125. If you were unable to do that, you can of course use the bus stop method or short division. So let's say that you didn't spot that. And if we go ahead and do that, 8 will go on the outside. We'll have 1, then we'll have now the zeros, and we'll have our decimal point. Does 8 go into 1? The answer is no. So I ask myself, does it go into 10? Yes, it does. It goes in once, remainder 2. Then I ask myself, does it go into 20? It goes in twice, remainder now 4. Does it go into 40? It goes in exactly 5 times. So you can convert from a fraction to a decimal by using short division. So if we had now, let's say we've got 1/3. This is one that we should just know. This is 0.3 recurring. It's not 0.3. 1/3 does not, and this is a sign for does not equal 0.3. 3/10 is equal to 0.3. Again, when I'm marking exam papers, common error. Let's say you're unsure. So let's use now short division to show that that is the case. So if we go ahead and do that, so what we'll have is the following. We'll have 3 on the outside, 1 on the inside, 0, 0, 0. I'll do a few of these. Does 3 go into 1? The answer is no. Does it go into 10? It goes in 3, remainder 1. Does it go into 10? It goes in now 3, remainder 1. Does it go into 10? It goes in 3, remainder 1, and I think you can see where we're going with this. So we end up with all of these 3's, so it's 0.3 recurring. So what does that mean for 2/3? Well, 2/3 must be 0.6 recurring. If you think about splitting now a pound into 1/3, it's going to give 0.3 recurring. If we got 2/3, it's going to be double that. Again, you can use this technique. So what about now 2/5? Well, with 2/5, if we don't recognise this to be 0.4, you could either use the short division, 5 on the outside, 2 on the inside, or you could think of this as a pound. If I have £1 and I want to have 2/5 of this, if I divide a pound by 5, that's going to give me 20p, or 0.2 pounds. Now I want 2 of those, which is going to give me 0.4 pounds, or 40p. So often if you're stuck, turn this into money and think logically. So that now is converting a fraction to a decimal. Right, okay, the other way, decimals to fractions. Some are just obvious. All we're going to do with this particular case, for example, 0.1 is equal to 1/10. If we have, for example, 0.23, this is going to be now 23 over 100. What have I done here? Well, let's think about this logically. These are tenths, so I'm going to have 1/10. These are hundred, or these are tenths, these are hundreds. So I've got 23 100ths. If I could simplify this, I would. So for example, 0.24, I've got 24 100ths. So 24 100ths. Now, if I didn't spot how I could do this, I could half it to begin with. That would give me 12 over 50. I can half that again, and that would give me 6 over 25. So in its simplest form. What about if we had, let's say we've got now 100, let's go for 0.117. Well, what I have here is now, these are tenths, hundreds and thousands. So I have 117 1,000ths. So that now is converting a decimal into a fraction. So let's go ahead and do those. Do try and break them down. Let's go to that one. So we've done fractions to decimals. We've done decimals to fractions. Okay, percentage to decimals. We simply need to divide by 100. So if you think about this now, if I've got 27%, this is equal to 27 100ths as a fraction, or we can say now that this is 0.27 as a decimal. So if I had 63%, this would be now 63 of 100 as a fraction, and as a decimal it would be 0.63. Let's say I had 52.4%. Now as a decimal we can write this as, and I'll just write it in here, we could of course write it as a fraction if you really wanted to. It would be less likely you'd be asked to write this. We could write this as 0.524. So entirely up to you if you want to. I mean, I don't think it's worth writing it as a fraction as such in this particular case, but all we would do is divide this by 100. As much as I'm against this, when we're dividing by 100, we move the decimal place 2 to the left. So if we're dividing by 10, we move it 1 to the left. If we're dividing it by 100, we move it 2 to the left. I don't like to think about it like that, but it is an option for you. Okay, so percentage to decimals, fractions to percentages, essentially we've looked at that in the previous part. Nice and straightforward. So for example, now if I had, let's go ahead and if I had, let's say 7 over 20, I'd need to multiply numerator and denominator by 5, so I'd have 35 over 100, which is equal to 35%. And we looked at a calculator method also. So they're all our conversions, so let's tick that off. Okay, multiplying decimals. When we're multiplying decimals, all we need to consider is the whole number. Again, we can look at the magnitude, the size of numbers, or we can see this as quite an algorithmic way. So a remember it rule. What I'm going to do is have 0.2 times by 4. What I like to think about here is how many digits in total do we have after the decimals to begin with. The answer is just 1. So all I'm going to do is write 1. I'm going to get rid now of the decimal and write that this is 2 times by 4. 2 times by 4 is going to give me 8. I started with 1 digit after the decimal, therefore I need to finish with 1. So instead of 8, I'm going to have now 0.8. And that makes perfect sense. 4 times by 20p is 80p. So let's now look if I had 0.2 multiplied by 0.4. I've got 2 in total here. And that's going to now give me the integer values, the whole numbers of 2 times by 4, which is 8. But because I've started with 2, I need to finish with 2. So I put my 8 in, and then I have a 0. So it becomes 0.08. Another way you might want to think about this is that you're multiplying tenths by tenths, which will give you 100ths. I really don't mind. That's probably a better way of looking at it and a deeper understanding of what you're doing. So for example, if this was 0.02 times by 0.4, our answer would be 0.008. As we've started with 3, we need to end with 3. Alternatively, if we're multiplying 100ths by tenths, so let's write this in, tenths, this is going to give us thousandths. So if either way round, it really doesn't matter how you view it. I prefer to see it this way, but on the foundation paper, if you want to see it purely as now the decimals, how many you start with is how many you end with, and then you simply replace the decimal. So let's try one more. Let's try 0.3 times by 0.05. I've got 1, I've got 2, I've got 3 decimal values after a decimal. So 3 times by 5 is going to be equal to 15. So my answer is going to be now the 15, but I need 3 of them. So it's going to be 0.015. So that's multiplying decimals. Let's go ahead and do that. Okay, so multiplying decimals is done. Okay, ratio. Let's move on to ratio. People dislike ratio for some reason. Ratio is just about sharing. Okay, so let's start with now simplifying ratios. So simplifying ratios is exactly the same as simplifying fractions. Let's say we had a fraction now and it was 4 over 8. We can write this as 1/2. If we have a ratio of 4 to 8, we can write this now as a ratio of 1 to 2. This is telling me someone has 4 equal parts, and this is telling me someone has 8 equal parts. It's exactly the same as saying someone has 1 equal part to 2 equal parts. We can simplify. So if we had now a ratio of 14 to 21, 7 goes into both of these, so it would be a 2 to 3 ratio. That is simplifying a ratio. Sometimes you'll be asked to write a ratio as 1 to n. So if we have now, let's say a 5 to 7, and we want this in the form 1 to n, all we do is divide both sides of this ratio essentially by 5. So we have 1 to 7 over 5. So that's a 1 to n ratio. If we wanted it the other way round, an n to 1 ratio, it would be 5 over 7 to 1. So all we're doing is writing it for one part. You get now 5 sevenths to 1. And that's a way we could do it n to 1. Let's just do one more. Let's do 4 to 9 ratio, and we'll do this as a 1 to n ratio. So we want this number to be 1, so we divide that by 4, which means I need to divide that by 4. If we wanted it the other way round, n to 1, we want the 9 to become a 1, so we'd have 4 divided by 9 to 1. So they're 1 to n and n to 1 ratios. Okay, let's look at ratio sharing. I've given an example here. I'll do a different example. I've won £40 and I'm going to share this in a ratio of 3 to 5. What I'm first going to look at now is the number of total parts. So total parts. A common error is to say there are 2 parts. There are not. The total parts are the sum of the 3 and 5. So total parts is equal to 3 plus 5, which is equal to 8. So there are 8 total parts. I'm going to have 3 parts, you're going to have 5 parts. So what we do is take the £40 and we divide it by the number of parts, and that gives us 5. So we can say 1 part is equal to £5. So I thought to myself, I've put this money in 3 piles and 5 piles of equal amounts. How many total piles have I got? I've got 8 piles. We work out what 1 pile is worth and then simply now multiply up. So this person's going to have 3 times 5 quid, which is 15. And this person is going to have 5 times 5 quid, and that's going to give us now 25. Quite clearly, these two numbers must add to give £40, as that is what I shared. So here's an example I've given here, £60 in a ratio of 3 to 2 to 1. 6 total parts, 3 plus 2 plus 1. 60 divided by 6 is 10. Each part is worth £10. Now, as you can probably see when we go on to the next bit, I've cut the last one off as it appears on the next page. 3 times by 10, so this person gets 30, the next one gets 20, and the next one gets 10. In the series on the harder GCSE questions, which is included in this whole programme, you will see some examples when they switch things around with ratio. So a nice switch around with ratio would be, let's say now Sue, and we'll write one here, Sue has 20 sweets, okay. The sweets, so she's got 20 sweets from a total amount. The original ratio was split, her and Bob, so Bob and Sue, let's write Bob and Sue, had now the sweets shared in a ratio of 2 to 5. And we might be asked how many sweets there are in total. So Bob and Sue had this bag of sweets, and here's the bag, okay, and they shared this in a ratio of 2 to 5. Okay, now Sue has 20 sweets. So if we think about this now, if she's got 20, what did we multiply 5 by to get 20? The answer is 4. Therefore, we've got to multiply the 2 by 4. Or what you could say now, and this is just an equivalent ratio. So the total number of sweets would be 28. Bob would have 8, she would have 20. Another way you could look at it is that 20 is equal to 5 parts. So if we divide now 20 by 5, 1 part is going to be 4 sweets. So if Bob has 2 parts, then he's going to have 2 times by 4, which is going to give us 8. And we know that if he has 8, she has 20, we've got 28 in total. So that's kind of working it backwards in a couple of different ways. You can write equivalent ratios, if you can find one. Or you can say, well, she's got 5 parts. 5 parts is worth 20. That means that 1 part must be worth 4. If he's got 2 parts, 2 times 4 is 8. So that's ratio sharing. Okay, let's just move on. Hopefully you'll see now that, we've lost it there. Okay, let's look at proportion. Now, proportion is often chucked in at the start or towards the end of start of a higher paper, end of a foundation paper. Let's look at proportion. What I'm going to do is write a recipe for cakes. And recipe ones are quite... so let's do this. What this is going to do, this is going to make 4 cakes. This is a typical question. So 4 cakes. What I'm going to have then is flour. Let's put flour. Let's put sugar. And then let's put eggs. Let's make this nice and easy. What else goes in? Flour, sugar, eggs. We'll say milk. Okay, so what I'm going to say, this makes 4 cakes. So the amount that we need, I'm going to say, and this will probably be a vial cake, 100 grams of flour. We'll have 200 grams of sugar. We'll have 8 eggs. And we will have, let's say we're going to have on here, let's say we're going to have 40 ml of milk. So this makes now the amount for 4 cakes. What I'm going to do is write an amount for 1 cake. So if this makes 4 cakes, 1 cake will be now 25, as we're dividing this number by 4. Sugar, we need to divide this by 4, which would give us for 1 cake 50 grams. If I divide this by 4, it would have 2 eggs for 1 cake. And then this one would be 10 ml. So if we were told now that these are the ingredients for 4 cakes and we wanted to make 5 cakes, then all we need to do is simply do 5 times by the 25, which would give us now 125 grams of flour. We could do now 5 times by the 50 grams, which would give us now 250 grams of sugar. Eggs, we would have now 5 times by the 2, which would give us 10 eggs. And then we'd have milk, we'd have 5 times by the 10, which would give us 50 ml of milk. Okay, that's one way you can do it. You can look at multipliers. Remember, you're simply adding a quarter on, or you're multiplying by 1.25. So if you wanted to multiply by 1.25. And this is where we go on to if we had 6 cakes. Now, would I work out what 1 cake gave me and then do that? Or could I say, well, actually, I just need to do 1.5 times this amount? 1.5 times by 4, so 1.5 times by 4 is equal to 6. So all I'd need to do is multiply these up. So I'd have 150, and that would be the flour. I'd have 300. I'd have now multiplying that would give me now 12, and then multiplying that would give me 60. So all I'm doing is multiplying these by 1.5. Or you could find half the amount and add it on. So lots of different ways. Either way round, you will need to be quite clear with your workings. Another proportion question, let's write another one. We might say 6 pens cost, let's say, 36p. We want to find out how many 13 cost. So how much would 13 cost? Well, let's think about this. We want to know what 1 costs. So 6 pens cost 36p. 1 pen will be equal to 36 over 6, which is going to be 6p. So if I want 13, I do 13 times by 6, which is going to give us 78p. So all I've done is worked out what 1 costs and gone from there. Typical questions, miles in an hour, we can just work them out from proportion. So if a man, let's say a man can walk 5 miles, so 5 miles in, let's say that this is going to be, let's say we say 15 hours. Okay, now how long will it take him to do 1 mile? Well, we can see that 1 mile will be equal to 15 divided by 5, which is going to be 3 hours. Pretty sluggish. So if we wanted to work out how long it would take him to do 7 miles, then all we would do is 7 miles will be 7 times by 3, and that's going to give us 21 hours. Okay, pretty long old walk, nearly a day to do 7 miles. Not ideal, but hopefully you can see where that's going. So these are proportion questions. Essentially, we're finding the value of 1 item, 1 mile, 1 pen, or we're making subtle adjustments. So for example, if I was doing 9 pens here, I would just multiply this answer by 1.5. If I was doing 18, I would multiply it by 3. Right. let's move on to unitary measures or best buys. These are now when we're in a supermarket, and nowadays it's pretty much done for you, but we're looking at the cheapest unit price. So we're looking at unit price. We do this by considering the price divided by the quantity, and we want the lowest. This tells me what each item is. So let's say I went in and there were some cookies. Okay, and the cookies, 12 cookies, and we'll make this quite hard. 12 cookies cost 89p. Okay, so 89p. Yet they had, let's say, 16 cookies. So, in fact, we'll make it 19, make it a bit messy. 19 cookies cost now £1.43, so 143p. Which is the best buy? What we want to do is find out the cost of one cookie and that to be as low as possible. So the price is 89, and do remember to work in the same units. So if this was £1.43, don't divide it by 1.43 because that's different to doing it to 89. So 89 over 12 versus now 143 over 19. This is going to work out which is the cheapest per cookie. So let's do 89 divided by 12. So 89 divided by 12, that's going to give us now that each cookie is 7.42p each. So approximately 7.42p per cookie. So we can write that in per cookie. And now let's do the next one. So we got the price. Price is 143. 143 divided by 19. And that's going to give us now on there 7.52, so 7.53. So that's approximately 7.53p per cookie. Let's jot this in. So which one am I going to buy? Well, I'm going to buy that one because they are cheaper. So one cookie is slightly less. There's not a lot in it. I'd probably buy this one because, just for the sheer heck of getting more cookies. But we can see price divided by quantity, and we want to consider the lowest. This is the unitary cost, best buys or unitary measures. We simply divide and compare. So that's a nice example. It will generally be a calculator paper and do show 4 workings. Okay, so that's pretty much the end of number. There might have been some subtleties that I've forgotten along the way, but hopefully these have given you the basic skills that you can work through and go from there. In this series, we do have some functional wordy questions that you can apply these to. So you're going to use these basic skills. But all of these skills are the ones that you're going to need to see you through your GCSE foundation level.